Okay, so as I told, like there are two VM that are running. The first is the Window OS VM, and the other is the Linux OS. And for this, for the whole lab, we need a connectivity between both this VM, the Windows as well as the Linux. So I will
Okay.
tell you like how can we achieve that. So what I'm going to do is when you go to the window, just click on edit. So I think the process will be somewhat similar for VirtualBox. And now
Again,
I'm
can you, I mean, can you make some distance from your
okay. Okay. Yeah.
speaker?
Yeah. Now,
Because yeah,
now
yeah,
it's
now it is clear.
okay. Okay.
Yeah,
Okay. 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 Yeah. Thanks. Okay.
yeah.
So the thing is now we have to edit the virtual machine setting. I think the process will be
Mm-hmm.
somewhat similar for the VirtualBox too. Okay. So
Okay.
yeah. So we'll go to the network adapter, and over here, what I have done is I have selected the host only. Okay. So
Mm-hmm.
by default, it will be NAT. NAT
Mm-hmm.
will kind of give you the net connectivity to the Windows VM. Okay. But for the
Okay.
labs and all, I don't think we need the net connectivity. And kind of it's good
Mm-hmm.
actually that suppose you are running the Windows VM or Linux on your like you have installed that suppose on your office laptop or something. So if you're running
Okay.
the malware, you make sure that you don't have the net connectivity to that Windows VM, because if some alert goes outside, then maybe yeah, there will be some kind of like kind of analysis maybe done in your machine. So it will be false alert to the your guys. So yeah,
Okay.
make sure that it's host only. And the same
Sure,
thing,
Prakash.
yeah, and the same thing goes for the same thing goes for the Linux OS too. It's host only. And now
Okay.
what I have to do is just okay. So I'm starting the uh, yes, I'm starting the Linux OS, and now I will just check the IP address what has been allocated to it. So if you
Okay.
see the IP address allocated to this one is something 192.168.246.129. Okay,
Mm-hmm.
and if I go to the just a minute. And if I go to the Windows,
Okay.
so I think the so if I go to the Ethernet and change adapter options, so I think
Okay.
I have hard coded the IP address over here. Okay, it's obtain IP address automatically. Okay, so I need so if you see in the if you just note down the IP address of this Linux OS is 192.168.246.129. Okay,
Mm-hmm.
so I will be trying to ping this machine from the Windows OS. So I'll just go
Okay.
here. Yeah, I'll just go here and then ping 192.168.246. I think 129, right? This was the
Yeah,
IP
but yeah.
address. Yeah. Okay, so the reply is coming from there, from 129. And let's see if I can ping this machine too. So I will just note down the IP address of this is 246.144.
Okay.
So I'll just ping 92.168, 246.4. Yeah, so I can ping both the machines. Okay, so
Yeah,
what will
but yeah.
happen is like when you'll be setting up, so there might be a case where so you have to first note down the IP address of this Linux machine. Just write it down on maybe on some notepad. Okay, and also
Okay.
make sure what's the subnet mask. So the subnet mask is
Mm-hmm.
255.255.245.0. Okay, so
Okay.
once you have done that, so what you need to do is like you have to go to the this one and make sure that the IP address has the suppose for this Windows OS the subnet mask is the same 255.255.255.0, and
Okay.
the IP address that has been allocated to this Windows OS by the VM is in the same
Mhm.
network. So it's also 246.144. So uh,
Okay.
yeah, so if you are all, I think you might already know that 255, this 3 octets should be same because it's
Yeah, yeah.
255. Yeah, so you can change that. So yeah, so here what is happening is actually uh, like by luck or something, the both the system are on the same network. Okay, but there
Okay.
might be a case where kind of it might not be in the same domain.
Same network. Okay.
Yeah. So the other thing is what you need to do so that when we execute the malware, we want that net connectivity. Suppose the malware is kind of doing any DNS query. Okay, and
Okay. Okay.
and this system is not connected to the internet, so that DNS query won't be success, right?
Yes.
Yeah. So what
Definitely.
I will do is I will run a fake DNS program in the Linux
Okay.
OS, and I will
Mm-hmm.
tell this Windows OS that your gateway is the Linux OS. That means it's kind of a
Okay.
router. Yeah, it's kind of a router to the Linux, to the Windows.
Mm-hmm.
So what I need to do is I think that when this option was selected, obtain IP address automatically, the default gateway might be something else. It won't be,
Yeah.
I think, the Linux. So yeah, so I will
It
just set that, hard code that, and so it was, I think, 144.
129.
Yeah, uh, yeah. For this 144, this is IP address of this machine. Okay,
Okay.
and over here I will just mention 246.129, right? I think that was
Okay.
the, yeah, 129. Yeah. So the default gateway, I have mentioned this. So all the connections, all the packets will go now to the Linux OS. And apart from that, I will also tell this machine that for any DNS query, again, go depend on the Linux OS. I will again give the same IP address of the Linux OS. Okay.
Okay. Fine.
Yeah. So yeah. So now what will happen, as you might already know, that all the queries, all the connections will now go to the Linux OS, and Linux OS,
Okay.
if it wants, it can either forward to the internet or maybe just block it till there. Okay.
Okay. Okay.
Okay. So I have done that now.
But
So
Linux OS will do those actions depending on the setting what we have done.
yes. So we need to run the scripts and all, because suppose I
Mm-hmm.
have done this, and if I show you the malware, if I run the malware, you will see like it is not getting success. So I need to run the fake DNS or any other server on the Linux OS. Then only it will be successful. Yeah.
Okay. Fine.
Yeah. 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 But the network architecture, I think, is clear, right? How we are
Yeah, yeah.
setting.
It is
Yeah.
clear. Pratik. Yeah.
Okay. Okay. Any questions, Saidit? No?
No, Pragya, no.
No? Okay.
No questions as of now.
Okay, okay, great. So what I will do is I will start with the malware now. And okay, so the malware is here, and thing is I'm just running the process hacker. So the malware is not running as of now. We can't see the srvcp.exe running. Okay.
Okay.
Yeah, and now I will start the
And
lab.
Pragyan, you're taking all these files from a shared folder.
Yeah, so what I have done is I have kept the malware in my host system. So I'm just
Okay.
kind of reading from there, and the shared folder is kind of set in a read-only mode. So if the
Okay.
malware try to do something like kind of encryption or something, it won't be success kind of thing.
Okay. Okay.
Yeah.
Fine.
Okay. Yeah. So for this malware, the story is like kind of you are the kind of investigator, and you got an alert from somewhere that the some connection is made from, so there is a, so there is a suspicious machine, it's not working properly and all, and someone
Okay.
does a basic analysis and they found was like, okay, it is that machine is trying to connect to a kind of port name as 6667, okay, 6667,
Okay.
okay,
Mm-hmm.
and kind of there is a suspicious process or maybe a new process that is running as shown in the task manager, okay, and the name of that
Okay.
process is srvcp.exe. Now you are given the
Okay.
task, and you're given the task to kind of tell, is that indeed a malware, and kind of if it is a malware, you need to kind of
Okay.
make a report out of that, like what's the behavioral analysis, what the static or code analysis, how that malware works, and kind of what's the capability of that malware. And once
Mm-hmm.
kind of you have made those kind of uh, got all those artifacts from that malware sample, you need to again
Okay.
kind of tell your network team that, okay guys, I have the host based IOCs as well as the network based IOC. Now
Mm-hmm.
you guys have to kind of take this IOC and do a hunt of the whole enterprise network and check if this malware are present in any other system, and also block this malware from coming to our network at a network level.
Okay.
Okay, so this is a
Okay.
task. So that's what we will start, and kind of we will analyze this srvcp.exe malware, and we will try to see what's the capability of this. Okay.
Yeah. Fine.
Yeah. Okay. So as you already know, the Procmon actually gives you all the activities that are happening on the system. Okay. So when you
Okay.
start, yeah. So when you start the Procmon, so thing is like it will automatically start capturing the event. So what you do is like you first press Control plus E. That will kind of stop the events from getting captured. And apart from
Okay.
that, you do a clear display. That is Control plus X. Now you
Okay.
need yeah. So when you do any malware investigation, start with this basic thing, that you clear your display
Mm-hmm.
and no other filters are going on. Okay. And
Okay.
now thing is like, now I have the srvcp.exe that I will be going to execute, and before that I will kind of quickly start capturing the event. So as you can see quickly, there are a lot of entries, and now I have executed the malware. And to confirm that, I see that srvcp.exe is running in the system. Okay. And it
Okay.
was ran 7 seconds ago, and all the details you can get it from here. And now I will, so the Procmon is actually capturing the event also for this malware. I think uh, we can now stop the capture. Okay. And let's see how this malware is running. And before that, what I can also do is, now we have some basics uh, artifacts of this malware. So I will, maybe for now I will terminate this process, just to make sure that we concentrate on the Procmon logs. Okay. So now the first thing, yeah, so now the first thing that I will be going is to the filter key, and kind of I will go to the filter tab, and over here I will select architect. The process name is, just go to this drop down menu, and you can select srvcp.exe. If that process is running, that thing will be showing up in this list. Okay. And this is something called include that I want to see, and then I add this in the filter. So when I add this, I will just keep apply. And
Okay.
now what is happening is kind of, I'm only seeing entries, if you see in the back, only for the srvcp.exe. Okay. And the other thing that Procmon does for you is that it
Mm-hmm.
already kind of tried to exclude a lot of process. Okay, like Procmon
Okay.
itself or proc exp, a lot of other process, so that the
Mm-hmm.
noise value is somewhat less. Like a lot of Windows activities also, like writing to the mft file and all, are all
Okay.
kind of excluded, so that it doesn't clutter up your display. Okay. And now I
Mm-hmm.
will just go over here. So we will now go and kind of see kind of what all activities are happening for this process. So the process got
Again.
started. Yeah.
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 So right now, if we are stopping Procmon,
Yeah.
will it stop all the processes? What is happened, or else even in the back end, it will be still capturing what is the process that is going in our system.
Okay, so thing is like I ran the process and I terminated that with the process hacker itself. And at
Okay,
that time, the Procmon was running. I was that it was capturing the event, and now
okay,
when the capture event was done, I actually stopped capturing the event from the Procmon. If you see, this is not checked out. Okay,
yeah, yeah.
now at this time it is not capturing the log. It's only for the instant that we captured, like just for some seconds. Yeah.
Oh, okay, okay,
Yeah. So when you also do the lab, you make sure like once you think like you might have the artifact, like suppose for the first 2 or 3 minutes of activity you have logged, you just stop the maybe you stop this logging thing, you stop capturing event. Okay. uh,
okay.
because thing is like the load is very high when this procmon is
Procmon
kind
is
of
run.
running. Yeah.
So again, like let us say if we capture 2 minutes of Procmon,
Yeah.
I mean, if we start capturing 2 minutes for Procmon,
Mhm.
so will that captured events are sufficient for us to analyze the behavior of particular malware?
Yeah, so actually it's not sufficient. But thing is like actually malware behaves a lot of differently. Maybe there it needs some certain files, or it suppose it is trying to connect to the C2 server. It will start
Mm-hmm.
behaving differently. So
Okay.
yeah. So I will say is like if it is fine, let it be running. Okay, let it be
Okay.
running. That's not a problem. But yeah, like for this case, we are now first interested in kind of just seeing the basic network activity or basic activity that the malware executed once it got started. Okay, so
Okay.
that's why I'm just stopping it from here. And other thing is like obviously now I will, for this malware I will be showcasing you that I will be making some changes to the kind of some settings and all, and you will see that
Mm-hmm.
the malware started behaving differently. Okay,
Okay.
once as per our analysis. So those all things will be covered over here. Okay. So
Okay.
as you can see, the
And
yeah.
again, like in real-time environment, we are not supposed to stop this problem. Am I correct?
Um,
Like,
yeah, it again depends on the analyst. So if the analyst wants actually kind of to just see the basic activity, he can stop that. And if he wants to capture all the activity, because thing is like suppose you are capturing a malware, okay, and
mm-hmm.
suppose so once one of the case that I have handled was kind of a ransomware attack where the malware came and kind of it was having a timer. So suppose it came on 24th of Jan, the malware attacker
Okay.
has set a timer that you get activated on 10th of Feb. Okay. So
Okay.
capturing the Procmon log over there won't give you anything actually because the malware has a
Yeah.
timer
Yeah.
over there. Yeah. So
Okay.
yeah. So we just see the basic first. We first start with the basic analysis, like suppose to see okay what's the persistence mechanism of this malware and all. So I think that will be getting captured in the maybe 2 or 3 minutes of thing. And
Okay.
once we do the code analysis, so we'll get further details. Okay, if there is a timer on which date I should run the procmon, so these all things can happen
Okay.
over there. Okay, so
Okay.
yeah. So the thing is now it's somewhat difficult over here to kind of see the logs or see the entry. There are a lot of things over here, and getting the filters also. Like suppose I don't want to see this load image entry or these all things. So it's very difficult in the procmon. So
Okay.
so the good case will be like if I can import this log to kind of an Excel sheet, okay,
Yeah. Yeah.
and yeah, and then kind of do a filter over there. So it will be really beneficial.
Okay.
Okay, so first I
Okay.
will go through like what this thing is. So if you see Windows, there's a prefetch file that is getting created. Okay,
Mm-hmm.
and the other thing is like whenever you see this create file entry, it doesn't mean that kind of that malware is creating that file. So with the name, you
Okay.
don't assume that a file is getting created, because many
Mm-hmm.
times when even the malware is trying to read a file, the operation entry will be create file. Okay,
Okay.
so the name won't give you uh, the feeling that okay, so the malware is creating a file. It can be two things. It can be either creating a file or it can be either reading the file. Okay, and
Okay.
yeah, and this registry reg open query and all is all linked with the registry thing. Okay.
Okay.
And so what I will do is now I will quickly kind of import this full log in a
Mhm.
Excel sheet. Okay. So I'll go to the
Okay.
file and I will go to, just a minute, I'll go to save. Let's see. Yeah, I'll go to the save and kind of
Mhm.
I will click on CSV. So because I want
Okay.
to load it in the Excel
Excel.
sheet. Yeah. So the
Okay.
native format is PML. Okay. So PML format is something you can suppose you have the PML logs. So you can again open that in the Procmon log in any other system. So it's
Oh,
a,
okay.
yeah, it's a native format of process monitor. So now I'm
Okay.
interested in CSV. So I'm just importing that uh, in the desktop. So yeah, so I think it got in the desktop. Let's see. Yeah, so log file, I have it now. And what I will do, I have my Excel software actually inside the, uh, okay, just a minute. Yeah, so I'll just copy this to my host machine. Yeah, and for now, just to save my CPU, I will just maybe suspend this for now because we'll be analyzing the log file. Okay, and I will go to here and open this log file. Yeah, so the Excel sheet has been loaded up. Okay,
Okay.
and yeah, operations tab, the path. Okay, and now I will go to the first column. I will go to the view, and I will freeze the top row. Okay,
Okay.
and now I will again go to the home folder and I will do a filter over here. Okay.
Okay.
Yeah. And now if I want to see only suppose create file,
Okay.
so I can see it now for this process, right? It's very easy now. So you can
Yeah.
see a prefetch file got created. As I told, prefetch file is something that is created by the Windows operating system. And it's like, it records all the details, like when the last time the process was run, when it was,
Mhm.
like what's the hash value of that process, and what was the
Okay.
actual path where this process binary was existing. So those all details are there, and this
Okay.
information will be very useful when you're doing any forensic investigation of a compromised system, because with that you
Mhm.
can tell the window of compromise. That is, with the prefetch file you can get to know the last time the process was run, and the created time of that prefetch file itself will tell you that what was the first time this process got executed in the system. Okay.
Okay.
Yeah. And now if I go over here, create file, if I go, so these are some of the basic things, some of the DLLs that kind of malware needs to be running. Okay.
Mhm.
Like the Windows socket, if you see over here, it's something related to network connectivity, the Windows socket. And yeah, I'm going down. Yeah. So now something interesting. Okay, so these all things seems good. Okay, like these are some of the DLLs that are window proprietary DLLs file. It gives you a lot of, like suppose for the CTR DLL.dll, suppose when you
Okay.
open some file for reading or writing programmatically or something, you actually calls open command. Okay, so those functions are actually implemented in this CTR DLL.dll. Okay, so these are
Mhm.
normal thing. But if I see something over here, it is trying to, if you see entry for some file called gus.ini, okay,
Mhm.
and the success is name not found. Okay,
Okay.
so this file is not existing at in this path, this gus. So what I will tell is like gus.ini is something that malware needs, and it is something that malware attacker has actually, so it's a kind of a text file, some kind of a configuration file, and kind of
Mhm.
malware functionality actually depends on this gus.ini file for this malware. Okay, and it is actually
Okay.
trying to search that file if it is existing in this folder. Okay, so if I, as I again told, that create file doesn't mean that the file is getting created. It means that it can be two things: either file getting created or something that it is the malware is trying to open that file. It is searching for that file. Okay,
Okay.
so
Okay.
here it is searching for that file to be read. So it is trying to read that file. So it is something suspicious. The gus.ini file is not a Windows file. It's something new to this
Okay.
system. Okay. So the
And
thing was,
again,
yeah,
how to differentiate, like you are saying gus.ini is
yeah,
not a Windows created file or else
yeah,
Windows created process. How to
yes, yes,
differentiate that whether it is a Windows
yeah.
created file or not?
Yes, yeah. So there are two things that you can do. First of
Mm-hmm.
all, obviously you can't know instantly, okay, these all files are Windows or these all files are not Windows proprietary. So what you can do is, normally what we do is kind of we create a hash line of, suppose I install a fresh operating system. I do a
Okay.
hash, I get the hash value of all the files that are present on that system. Okay. And
Okay.
now when I'm running this, suppose this logs and loading all this, like suppose I have the path of all the DLLs over here. So if that
Okay.
hash matches with the hash that I already have, so that means normally that these files are existing prior to the system getting infected. And I can tell
Okay.
without even knowing about this DLL that, okay, these are something that may be related to the Windows operating system. Okay. But for
Okay.
this,
Okay.
yeah, but for this, for this malware sample, this was something that we didn't found this hash matching with some any other file. And the other thing was like, uh, that malware attack happen in stages. That first and
Yeah.
yeah, first thing is like, they try to get a hold of the machine, and then
Mm-hmm.
they will give you a normal kind of some PowerShell script which will be just downloading something to the system, like
Okay.
downloading the malware, and then that malware might be running. So what is happening for this sample, actually there was a PowerShell script, okay, which came into the system, and kind of it actually downloaded uh, two files. First was gus.ini file, which it
Mm-hmm.
saved in this path as well as system32 directory folder, as well as the
Okay.
srvcp.exe malware. Okay, and
Mm-hmm.
now the malware actually depend on this ini file. Okay, so that was the
Okay.
scenario, basic scenario. Okay, and
Mm-hmm.
now in this lab we are directly actually analyzing the srvcp.exe. Okay, later
Mm-hmm.
when we will go into the session 2 and session 3, we will actually go to a scenario where we will be first starting with the analyzing of the PowerShell script. Okay, and we'll
Okay.
see like what it is downloading and what all activity is doing in the system. But for this
Mm-hmm.
scenario, we are directly analyzing the malware. Okay, so the
Okay.
information that we have got is that this file was existing in system32 folder or syswas64 folder. Okay, so
Mm-hmm.
I will just ask one question. Do you know what this syswas64 means?
Uh,
Any idea? Any guess?
no, but again.
Okay, so thing is, you will see this in a lot of systems. Okay, so syswas64 actually means, if you go to this folder as well as system32 folder, you will see almost all the files are same inside that, both the folder. Okay, so
Okay.
syswas64 is actually the 32-bit version of system32. Okay, so when you are running anything that is 32-bit of version, for backward
Mm-hmm.
complete compatibility, Windows tell you, okay, you can find the DLLs that are made for 32-bit version in this folder, syswas64. Okay,
Okay.
you got it now. So suppose
Yeah.
you're
Yeah.
running any 64-bit software, it will get those DLL from system32 maybe. Okay, and if
Mm-hmm.
you're running any 32-bit version, it will get the same DLL but from the syswas64 folder. Okay,
Okay.
yeah. So I'll go again, and yeah. So this is a 32-bit malware. So it's kind of trying to access this syswas64 directory and just checking if gus.ini file is present over there. Okay. And
Okay.
now what we will do, I have the gus.ini file. Okay. So what I
Mm-hmm.
will do is I will showcase you. Okay. First, I will showcase you what are the activity that it is doing, the malware is doing in the system. But after the basic analysis, when I will
put that gos.ini file inside this folder, you will see there's a drastic change in the behavior of the malware. Like it will be trying to
Okay.
connect to different IP address now, or different port number
Mm-hmm.
it will be running. So those all things will start happening. Okay, so that
Okay.
means that malware is highly dependent on this system. Okay, so
Okay. Okay.
yeah, so I will just pause the recording for a time recording. Okay, so I will repeat it again. That's now suppose there, because I forgot to start the recording. Okay, so
Okay.
there might be a case where suppose the malware is trying to connect to a port in the first 10 seconds. So going from a process tab to a network tab might take time, and maybe that entry goes down. You can't see that entry, right?
Yeah.
So yeah, for this the entry is there, but for other malware might that entry not be there. So what I can do, I can
Okay.
use a software called Tcplogview. So what I will do is I
Mm-hmm.
will again, just for this recording so that nothing get missed in that, I will terminate this. Yeah, so I'm terminating this and I'm executing the Tcplogview. So now it's blank. And as soon as I execute this malware, you see an entry comes up over here. And over here,
Mm-hmm.
you can see the port number on which is listening and the process name. Okay. And even the
Mm-hmm.
process path. So this
Okay.
thing is the first network based IOC that you can give it to your network team and kind of
Mm-hmm.
tell, okay, if any system is kind of uh, trying to, okay, even though so if there is any system that is trying to connect to port 113, that means that
Mm-hmm.
yeah, that means that that system is kind of compromised with the same sample that you are analyzing, that is srvcp.exe. Okay, okay,
Okay.
yeah, okay. And now what I will do is I will go to the Linux ones. I hope nothing is running. Okay. And now I will, so this is something, okay, I got from a TCP log view, but I want to know, okay, in this port, if there is any communication that is going out, right? I want to know,
Okay.
know that. So to know that, I have to use another tool called Wireshark. Okay. So are
Mm-hmm.
you aware of that tool?
Yeah, Pragyan. Like
Yeah.
whatever the analysis that we do
Mhm.
is based on Wireshark only,
Okay.
because
Then,
our
okay.
product highly depends on PCAPs.
Oh,
So
okay.
we will capture all the PCAPs, and we will see what is the communication it is making, and what is the IP addresses it is communicating to, and what
Okay.
is the URLs that it is communicating.
Okay.
So
Okay.
whether those communication is clean or not. So I am more interested in something like this Wireshark, because
Oh,
that helps our job more easily.
hmm. Correct.
Yeah,
Yes. Yeah,
because I
definitely.
might learn different perspectives how you are looking in a
Hmm.
PCAP or
Hmm.
Wireshark thing.
Yeah.
So which will help me a lot.
Yes. Yeah. Yeah. Definitely. Yes. And so, just as because this Wireshark talk got started, so have you also
Mhm.
explored Fiddler tool? Fiddler.
Fiddler, no problem.
Okay, so I will tell you one thing where the Wireshark might fail you is that suppose you are having an HTTPS encryption channel, like the malware is having an
Yeah,
is
yeah.
communic.
Even I was about to ask this question,
Okay, okay, okay,
because
okay. Yeah,
when this HTTPS communication or TLS communication is happening,
yeah, yeah,
there whatever the communication that Wireshark captures, it
yeah.
will be encrypted. You will not be able to see anything there.
Yes, yeah,
So
yeah.
yeah, Pragya.
Yeah. So in so that fiddler which actually works in a lab environment only. So suppose the malware is actually trying to connect to a C2 server over a HTTPS protocol, and you can't see the communication as you told in the Wireshark, but then you can use a tool called Fiddler. Maybe I will showcase that later, not for this malware sample, because it is not communicating to HTTPS as of now. But later samples are there which does that. So in Fiddler, actually you can see the decrypted data that is going out. Okay, so actually that will be a huge advantage. uh, uh, I'm audible, right, to all of you? Hello?
Yeah, Pragya, you are audible.
Okay, okay, okay. Yeah, so yeah, that is one of the advantages of that tool. You can actually see the decrypted data in that. So what it will do is actually it will show you all the process that are running on your system. Okay, and then it will show all the data that is going out from that process to the outside network, and as well as it will show you the HTTPS data in a decrypted format, because when the fiddler start, it actually sets a proxy server for you, and post which it is as it's a proxy server, all the connections go through that fiddler, and it is able to decrypt that with its own certificate authority keys and all, and you will be able to
Okay.
see those data. So that's a huge benefit. Like for a lab environment, it's a huge benefit. Like, okay, what data is going? Suppose a malware is actually kind of like trying to maybe get hold of some confidential file, encrypt that and kind of transfer that outside. So you can use Fiddler and see, okay, are there any doc file that is going outside? You can just see the data in a plain text in a human readable format. Okay.
Sure,
So
okay. I
yeah.
mean, we will see it in the later part. So
Yes.
once I'm a bit familiar with it, I will implement it in my laptop
Yeah.
as well, where
Yes.
whe-
Yeah.
wherever this encryption related files are there, then I
Yeah.
can use Better and
Yes.
read it, uh, which might help in my investigation.
Yes. Yeah. Definitely. Yeah.
Yep.
Okay. So by mistake, what I did was like I terminated the explorer.exe itself, and all the GUI went down. So I have to restart that again.
Okay. No issues.
Okay. Now. So process hacker is running, and now I will start the Wireshark.
Mhm.
So as you can see, there's a spike in this Ethernet 0. That means it is active. The data are going out. Yeah, I know you're already aware of all this thing. I don't know how to explain.
Yep.
Yeah, yeah. So I'll just quickly try to scroll this. Okay. And now it is capturing, and now I will do is I will execute that file. So a lot of other entries are there. And
Mhm.
I'll go to this and I'll execute this. So that process is running, I guess, as a VCP. I'm not seeing it over here. Yeah, it's running. Okay.
But
Okay.
is there
Yeah.
any reason why it is not showing here?
Yeah. I think it's showing over here. Okay. In the SRVCP.
Okay.
But thing is, I by mistake I exited that explore.exe.
Explorer.exe.
Yeah,
Okay.
and now it is not able to show that in this kind of format, the tree structure. Okay.
Okay. Okay.
Yeah, that's the reason.
Fine.
So there's, yeah, it's a kind of a bug in the process hacker, I will say. So now I will stop
Okay.
this. Yeah. So
Mhm.
now I will stop this, and let's see what all things get captured. Okay. Yeah. Got it. Okay. So if you see over here, there is some
Mhm.
DNS entry, right?
Yep. Yep.
And
Yep.
yeah, if I just quickly open that. Yeah. So the thing is, when I executed the malware, it's actually
Mhm.
was doing a DNS query, okay, to this
Okay.
website, irc.mcs.net. Okay.
Okay.
Yeah. And the port number of DNS is 53. That is showing up over
Yeah.
here, the source port.
Mhm.
And yeah, source port is
That's a
55.
UDP communication.
Yes. And source port 55918. Just let me do one verification. Okay, so if you see that range of that port, the source port 559118 actually falls under sbc host.exe somewhat. Okay, if you see the range and all. Okay,
Okay.
that entry is currently not showing over here, but thing is it's actually falling for this exe file svc host.exe. Now
Uh-huh.
there might be a question. Okay, that process is running. uh, I'll just, that process is running PID value 545716. Okay, it's running with this PID, but why kind of the
Okay.
source port in the Wireshark is showing as 55918, and which is actually related to, for this case, with my research, is that is related to the svc host.exe. Okay, so the
Okay.
question is why it should be related to the malware sample, not the svc host. So the reason is for that is whenever there's any DNS query that is happening
Uh-huh.
from the window operating system, that DNS query is actually handled by the window process itself, that is svc host.exe. Okay, so
Okay.
it
Okay.
doesn't mean that that process that is doing the DNS query is infected. It means it's
Yeah.
just,
Yeah.
yeah, it's just normal. Okay, it's just normal activity.
Okay.
So that thing you have to note it down, that okay, even though that some DNS query have been made, doesn't mean that that process ID or that port number on which this thing is linked is kind of linked to the malicious
Malware.
process.
Yeah.
Yes. Yeah. So let me see. Yeah, you can see it is running still in the 113. It's a very good malware. It's running the same port number. So yeah.
Okay.
So yeah, SBC host is something that has done this query. And now thing is, what I found with like, okay, it is doing some DNS query. So now thing is, this detail I was not able to get neither in the process hacker, uh, neither in the
Nor in the
TCP.
Procmon.
Yeah, not in the Procmon. I need to check once. I think maybe it will be there. Okay, why it
Okay.
is not there? Why it is not showing up? Because we have made a filter for srvcp.exe, right?
Yeah. Yeah.
Yeah, and because this is done by SVC host, that why it is not showing over there. But it will be recorded actually in the Procmon. Okay.
Okay. Okay.
Yeah, yeah, so that's why so now that's why we need this Wireshark software, and we got to know, okay, the malware is doing a DNS query, like if it so so previously there was the communication used to happen over IRC channel. So there was an IRC website, internet relay channel, something like that, and a lot of communication used to happen. It's similar to our WhatsApp group, how we do that. So and malware can actually, or any user can actually join a channel and kind of communicate with their respective person. So suppose I have made a group, I made a channel called ABC, and you know about that. So you can just go to the IRC software and just give the channel name ABC, and you can just directly have a communication with me. And if a lot of users are again added to that, I can again communicate to that. So it's similar to WhatsApp group. So now what
Okay.
happened is, like, suppose I have installed the malware in like 1,000 system. I will tell them, okay,
Mm-hmm.
you guys join this channel ABC in IRC channel, and now with the
Mm-hmm.
same channel I can handle all the malware
Okay.
instance, right? All the bot kind of say, yeah. So this
Okay.
is one of the DNS query that was been made, irc.mcs.net. And now if you see,
And Pragyan, like how
yeah,
we are concluding that this DNS query is made by the SVC uh,
okay,
malware.
okay, okay. Yeah, so thing is, like, for here in the lab, actually, if you see there, you can make a kind of, again, a whitelisting kind of thing, that okay, these all things are fine, like DNS for Microsoft and all. And two things you
Mm-hmm.
can do. You can tell, okay, these all things are normal or old thing. I know this is stuff. Okay, this Microsoft or google.com, these all things I know. I see something new website that the DNS query has been made to, and this DNS query was made at the same instance when I executed the malware. Got it right?
Okay.
So what you will do
Okay.
is, like, you execute the malware, you note the town, you note the time with the seconds,
Mm-hmm.
and at the same time you quickly see the Wireshark and see, okay, what all activity happened during that time frame. And you will see, okay, the
Okay.
DNS query were made. That's how you can, one of the easy way you can kind of relate that activity to the malware. Okay.
Okay. Fine.
Yeah. So, so the good thing over here is, like, I'm seeing the DNS query being made. Okay. If you see the standard query, but do I see DNS response over here? I don't think, right?
No, Pragyan.
So queries are being made, but there's no response. And as you can see, there are a lot of DNS packets. If I get even a single response from the first packet, the other packets won't show up because DNS has been resolved. So DNS is not getting resolved, and there are a lot of kind of DNS packets that is like getting generated by this malware is generating or trying to connect to get the IP address of this website, irc.mcs.net. Okay,
Okay.
so my task is now, so I got the first basic network based IOC that DNS query is being made. So any system that queries for irc.mcs.net, I can take that, tag that as, okay, this is something got compromised with srvcp.exe, right? And
Okay.
now I want to know, so suppose,
In this situation, like irc.mcs.net URL not required to be malicious, right?
yes,
Or
not
else
required to be
is
malicious.
it malicious?
No, it's not. It's not malicious. It's a normal website, irc.msjs.net. It's not malicious. So even kind of, I will tell you, okay, here, okay, you are telling, okay, irc.mcs.net is not malicious, but when some system got compromised, suppose, and it is like you again have something called, okay, uh, suppose there are 1,000 system in a company and not all system communicates with irc.mcs.net, but there are some system
Okay.
that is communicating in the same time frame. So then you can make, okay, in those 10 system, I think maybe 8 of them are compromised. So then again you need to do some further analysis. That's why I told, like, it's a basic IOC. You can't be 100% sure that system is compromised, because as you told, yeah, the website is not
Everything.
malicious. Yeah, correct.
Okay.
So now I want to see, okay, what if I make some changes by which this DNS query get resolved, and I want to see the next features that get enabled so by this malware. So what are other functionality the malware will activate if the DNS query has been resolved? Okay,
Mm-hmm.
so my task is now to kind of achieve that. What I will do is kind of, I will run a fake DNS server on
Mm-hmm.
Linux OS. And what it will
Okay.
do is when the DNS query are being made, it will
Mm-hmm.
give a fake reply to the malware. Okay. Now what will
Okay.
happen once it has the fake reply? Okay. As you know, DNS, first we get the IP address and then we try to connect. So what will happen is, like,
Mm-hmm.
once it has the IP address, the malware doesn't know that it is running inside a VM and we are giving a fake DNS response. So it will try to
Okay.
connect to that, and maybe when it is trying to connect to that website, it will give some more
Mm-hmm.
details of that, like which channel it is trying to communicate to and all the other details, right?
Yeah.
Yeah, so I will now start fake DNS on Remnex Linux OS, and I will showcase you, okay, DNS response are now receiving, and we will see, okay, what's the new thing. And the other thing is, you can note it down here, because we have made the gateway of this Windows OS to the Linux OS. That's why the destination of DNS query is again going to this Linux OS itself. That's the basic thing that we have to make sure, right? Got it?
Everything.
Okay, okay, fine. So yeah, again, I need 1 minute break. Just give me. Okay.
Yeah. Sure. Brother.
Thanks for reminding. Yeah.
It's
So
fine.
yeah. Okay. So now to repeat myself, I will be now running two things, two software in Linux OS. The first is the fake DNS server, which will kind of give a fake DNS response to the malware. And second, I will also run a fake IRC server, just to see, okay, once that malware get the IP address, what channel or what communication it is happening with that fake IRC server. Okay.
Mm-hmm.
So yeah, so to, and the other thing is, like, I'm just asking a question to you, like, okay, suppose I'm having a TCP communication with google.com or something, and
Okay.
some HTTP website, and I want to see that, okay, what all client and server talks are going on. How can I do that? Any guess?
Uh, Client and server.
Okay, I think my questions might be confusing, so I will just showcase that. How I think you might agree with that. So for a TCP communication, we will just go to the follow TCP stream,
Yeah,
right?
yeah,
Yeah,
yeah, yeah.
yeah,
Yes, yes.
yes, yeah, and we can see the maybe the get request and the get and HTTP request and
Yeah.
HTTP
What is
response.
the communication that happened between these two IP addresses?
Yes, yeah, yeah. So for the
Yeah.
TCP, we can see that, and again, if over the TCP there is the HTTP protocol that is running, so again we can see the
Mhm.
HTTP request and response, right?
Yeah, we
Okay,
can
okay,
see from this part.
okay, great. So I will just quickly go and kind of kill this process, and I will also close this process hacker one. And I will see if no. Okay. Okay. So I'll go to the Linux OS, and
Mm-hmm.
as you can see, I have the proper net connectivity to the Windows OS. I will first go to one of the tab, and I will type fake DNS. So this is the same. This is a very small command. It does everything thing for you. It sets up a DNS server. It will give the response to the Windows OS and all. So I run this, and you can see the queries have already started coming from the Windows OS, right? So there
Mm-hmm.
was a query for dom.query website, something like that, and this software fake DNS has responded the Windows that website actually exists on this IP address, and this IP address is
Yes.
the IP address of the same
It,
Linux OS itself.
yeah, but
Okay, and now I will also do is just a minute. I will also start the fake IRC server. So to do that, I will do ircd start. So these all commands are inbuilt in the Ramnex VM. Otherwise, it will
mm-hmm.
be a huge task to kind of, yeah, otherwise a huge task to set up all this. So it's all inbuilt in this. I'll just do ircd start. Okay, it's starting, it's done. And now I will,
What is this IRCD plugin?
okay, it's a command actually to run a fake IRC server.
Okay.
Okay, and not I actually don't use the fake IRC server. It's to run the IRC server. Okay, in locally
Okay.
in your system. Okay, and
Right.
now I will go to the Windows, and now I will execute the srvcp.exe again. And before that, I will also do the network-based logging.
Mm-hmm.
So go to the Ethernet.
Okay.
Yeah, and let's start the process. Yeah, now you see a lot of things have changed. You see over
Yeah,
here,
Pratik.
it queried and it got a response to a DNS response, and
Yeah.
that this website is actually connect having on the this thing on the Linux OS VM. Okay, and
Yeah.
then once it got the website, it actually made a connection to that website, and then it is
Mm-hmm.
doing some kind of back and forth response and all the things. Okay, and you can see some name also. I think it is trying to join that IRC channel, okay, with
Okay.
a name called Nick. Okay, got it?
Okay.
Yeah, so let's see that, and also let's see the network tab. So VCP, yeah, you see now the malware functionality got changed. You see the malware is
Yeah.
running on port 113, but now there's another connection that malware has made to a particular IP address on a particular remote. So the IRC channel might be running. So it is trying to connect on port number
Mm-hmm.
6667. Okay, so these things we were not seeing actually when kind of we ran the malware, but after we gave it the fake DNS response and fake IRC server, it so now we are seeing more functionality of this malware. We are seeing more behavior analysis functionality, and we are now have more network based IC. Okay, that now something that if any software running on any Windows operating system in your enterprise are trying to connect to 6667, that's again a huge kind of thing that okay, that system might be compromised. Got it? So this is another
Definitely.
IOC that you can use. Okay, and now I will see. Okay, these all things are set. Now we'll see what this Linux OS has to show us. I'll go this.
Okay.
And yeah, I will go to the fake DNS, and you see over here the IRC request was made and a fake response was sent to it. So this is how you can also confirm that okay, fake DNS is actually running and it is sending a fake response to the malware. Okay,
Okay.
and now the thing is I want to see that okay, what's the TCP thing that is happening now. What I will do is quickly I will go to the follow TCP channel, follow TCP stream, and you can
Mm-hmm.
see all the details now. It's very clear, right? That
Yeah.
and also thing is like most of the malware actually has a lot of offensive word that they uh, embed that we can't do anything. It's all depend on the malware attacker. So these all things we have to see sometime when we are doing some analysis. We have to we face this offensive uh, text while kind of analyzing the malware. So just to say it is kind of doing something like joining the channel with some maybe the username Mikey or something, and joining some channel. This has something, this is joining the channel, and then it is kind of doing some other activities over there. So these all things we got because we did a follow TCP stream. Otherwise it will be very difficult for us to kind of follow each packet and kind of do the things. So
Yeah.
I'll just yeah, the same thing. So I think that IRC channel is not giving sending further response. Okay,
Yeah.
uh, or it is waiting for the attacker. It has joined the channel and it is waiting for the attacker to give some commands. Okay, on that
Okay.
same channel, and once it get that command, it will actually execute that in the system and then again send the response back to the attacker. Maybe suppose I do something like okay, search for all the confidential file, all the doc file. So I'll give this command. It will do a system-wide hunt for doc file, and then when it get that list, it will transfer all the file to the content the same channel. So this all thing. So now it is connected to the channel and it is waiting for kind of any response from the attacker. So this is something that you can see from the network-based thing. And now what I will do is I will quickly take a screenshot of that so that yeah, and I'll close this, stop this, and let's see this. Okay, now the thing is we saw okay, this is the port number that is connected to 6667. Okay, and now previously I'm audible, right, to everyone?
Yeah. Okay. You are on.
Okay, okay. Now the thing is like in previously I talked about some file called gus.ini file, right?
Mm-hmm.
Yeah. So now what I will do is I will put that file in the same directory where it was searching that, and we'll see if there's any kind of like difference.
Again, little disturbance is coming.
Okay, okay. Yeah,
What
and now it's
happened?
fine.
Yeah. Now it's absolutely fine.
Okay, great. Okay. So now I will again terminate the process. Um, let terminate this process too. Shit. So I'll again terminate this srvcp file. So yeah, it's terminated, and let's just confirm that again. Yeah, so it's terminated now, and what I will do is I'll go to my folder, and this was the file, right? That it was looking for, as you see in the Procmon log. If I just go over here, and I want to see what's the path of that, so I will go again, go to the view, free pan, and freeze top row, home, and then again do a
Last time it was unable to locate that file.
yeah.
It was
Last time it was yes. Yeah.
it was trying to locate that file, but that file is not there.
Yeah. So this time what I will do is we will try to, okay, just a minute. I'll go to that entry now. Yeah. So this was the file that it was trying to locate. Yeah, as you told.
Mhm.
And what I will do is the same path. I will now keep this file. Okay. So
Okay.
let's do that.
Again, are you doing this
Uh, yeah, I have to do that in the
in your
VM. Correct,
system?
correct. Yeah. Sorry.
Yeah,
Yeah.
yeah.
Yeah. So yeah, I have to do that over there. Yeah. Thanks for reminding me. Otherwise, I would have infected my system.
Yeah.
Okay, let's do that. It's Windows, then sys464. It happened many times. Like you get confused what the host and guest, and
Oh, okay.
yeah, you
Okay.
end up yeah. So okay, so in this folder, it is trying to execute. It is searching for this file. So I'll do that, and now this file is there. Okay, so
Okay.
I'll show you the content of this file. Let's see the content. So nothing is readable. It's all encrypted or maybe encoded or obfuscated. Okay.
Okay.
And yeah, so my task actually now is actually to see what the malware activity got changed if I keep this file over there. And second thing
Okay.
is the heavy task will be to decrypt this content. Okay,
Okay.
so to decrypt that, as you might recall, guess we have to go now. We will be transferring from the behavioral analysis to the code analysis to kind of
Okay.
decrypt this file. Okay,
Mm-hmm.
so yeah, so let's go to restart the packet capture just to see if anything new comes up. And this time I will execute this malware sample as an admin mode. Okay.
Okay. Last
Yeah.
time we have not
Yeah.
done it.
Not yes. Yeah. So this time I have done that in admin mode because you also saw like there were like entries that it was trying to connect to run entry and all. It was access denied.
And where
Uh,
access got denied.
yeah. Yes. Yeah. So I think now with the admin privilege, because you see the integrity is high, I think um, maybe because of that now it will have the feature to kind of yeah you see the process elevated pop-up is coming now. So yeah,
Yeah.
it's running in the admin mode, and now as I have given the things, let's see what's the change happening on the network level. So you see something, any difference you can tell from this entry that I have highlighted?
Okay.
So any
Um,
change that you are seeing from the previous entry and now in the new entry, any guess?
so this srbcp.exe is running in port number 113, and it is communicating to different port number
Yeah,
double six
yeah,
double six. Previously it
yes,
is double six six
six
seven.
seven, yeah.
Now it is
Yes.
double six double six.
Yeah. So thing was like being an incident response team. Suppose you are, and you get a response that okay, something is running in port number 6667. Okay, and
Yeah.
so you were searching for, you were hunting for the enterprise for any any system that is running, any process running connected to port number 6667. You got the data. Okay, and you
Yeah.
actually save those system from getting compromised. But now what happened was that those malware were not actually running in a admin privilege, as well as that file geos.ini was not in present in that folder. That's why it was running in 6667. Okay,
Okay.
so now thing is, if I have done that, I would be really happy. Okay, I have saved all the system from getting which were compromised from this malware, but it's not correct because I have missed
Yeah.
something. Yeah, now because I am doing an analysis, I know that
Hmm.
when that file is present over there, and when the system, when the process is running with admin privilege, it's actually connecting getting connected to some different port number, 6666. So that's how
Yeah.
my IOCs were not complete actually, right?
Yeah. Yeah.
Yeah. So
Yeah.
that's where you can see, okay, what's the importance of doing a malware analysis for a normal incident investigator. He will be very happy that he gave the IOC in a very quick turnaround of time, maybe in 1 or 2 minutes, but that's not complete. There might be a lot of systems which are compromised, and even where the process is running in admin mode, right? So
Okay.
that's where this knowledge will really help you. So now we see a totally change of the functionality. The malware is now running on 6666, and let's see if anything changes, anything new coming up. Yeah, everything is same. Let's see anything new coming up on the Wireshark. So I will stop this. And, oh, you see,
Okay.
and I will show you the screenshot that I have taken. uh, okay. Yeah, so the channel was something different, right? In the first
Yeah,
one.
Bragyan.
Yeah,
Yeah.
and
Yeah.
now it is something different. So that's a huge change actually in
Okay.
the kind of channel or the activity that malware had achieved after it got the file. So now we will even think, okay, the channel is something, the old one, but
Okay.
we will try to block that, and but it won't be a full sweep out, because the original
Yeah.
channel that malware will try to connect is has my tags with some key called soup. Okay, so IRC might be
Okay.
having some parameters that you join this channel, maybe with a username called soup or maybe my key. Okay, so there's a huge change now of the malware
Yeah, Bragyan.
functionality. Yeah. Yeah. Okay, and even like thing is like, suppose I got some basic IOC, I have not done a malware analysis, I try to block that channel, or maybe
Hmm.
inform the IRC server that okay, you stop that offensive channel. So thing is, even
Okay.
the malware attacker will know that okay, some investigation has been started on
Okay.
his thing, and malware
Hmm.
attacker is happy that no one has still not know what's the correct channel, but he will get an idea,
Okay.
okay, this is the decoy channel, and someone investigation has started. So it will be, maybe there are cases where suppose a malware attacker get a hint that investigation has started, it actually becomes actually become more aggressive. They might change the
Okay.
functionality to some kind of ransomware and encrypt all your files just to take an revenge. Okay, so
Okay. Okay.
yeah, yeah. So this is something, the new thing that we saw. The channel
Mm.
got changed, and it is trying to connect that. Okay, so to say the behavioral analysis is now complete for this this malware process. Okay,
Mhm.
and as I told, like you can also use the automated analysis tool like virus total and a lot of other thing. But I can
Mhm.
tell you for sure that even virus total and other automated tool won't give you these details. It will give you details like
Okay.
okay, the normal thing, okay, something is connected to 6667 and all the things, but you won't get the other details, right? So those details
Okay.
you need to have the knowledge of malware analysis, and by which you can get further details. Okay, so So I will stop the behavioral analysis now for this. And
Mm-hmm.
maybe now, if you want, let me see the time. It's 11:20. So what I will do is, if you are fine, I will take another 2 minutes break, and
Okay.
I will start with the code analysis now. And my task over there will be to kind of see the code, what the code are there, or what are functions are there, and if I can decrypt that gus.ini file. Okay, so
Yeah,
that's
sure.
what my task. So I will take. So if you're fine, right, with proceeding with
Yeah,
that.
yeah, fine, fine.
Okay, okay, fine. So what I will do is I will again take 2 to maybe 5 minutes of break, and then I will start with the code analysis tool. And over there, I think that's one of the major thing that you guys are waiting. So I
Yeah,
will,
yeah.
yeah. So I will start with the IDA Pro tool, and I will analyze the assembly language over there. Okay.